Certainly people were aware of the urban heat island before the heat wave, but after the heat wave of 1995 and the still significant one of 1999, I think the city is much more aware that a few extra degrees can make a difference. If the prevailing meteorology is already giving you a temperature of 90 or 95 degrees, that extra 5 degrees from an urban heat island, pushing it up to near 100, is going to make a significant difference in the heat stress that people feel. And not just heat stress in people, it's going to make a significant difference in the demand for energy. Modern cities differ from these earlier cities in a couple of important ways. One is we have a lot more concrete than did the early cities. And so concrete tends to hold on to its heat energy quite efficiently. That would tend to promote larger heat islands today than in the earlier cities. One of the things I'm interested in is the role of atmospheric particulate matter in modifying the amount of sunlight that gets to the ground. And it so happens that about 25 miles down the road, Argonne National Laboratory has a database that goes back more than 30 years now, measuring the total amount of solar energy that gets to the ground. Now, of course, there's huge variability associated with weather, with clouds coming and going. So to interpret that database, one would have to know something about meteorology, but then there have been major changes in air quality over that period. If those who were in Chicago around 1970 know that the air quality was considerably degraded compared to what it is today. And so one of the questions is, are there trends in the amount of sunlight that gets to the ground? And of course, the amount of sunlight that's absorbed at the ground is one of the main factors in determining the local climate. What you're looking at here is a Brewer spectrophotometer. It's made in Canada, and this is the current standard for measuring the intensity of the sun's ultraviolet radiation at the ground. This little dome that you see here is an optical entrance where ultraviolet sunlight enters from all directions. Now, of course, here it's a cloudy day, so we're getting hit by light from all directions. Even on a clear day, though, a lot of the ultraviolet sunlight that gets to the ground is scattered diffuse radiation. So even though the sun may look very important to you in the visible and the ultraviolet, you really have to look at the entire sky. It's interesting that today there are satellite instruments in orbit that were designed for things other than looking at urban heat islands, but the data are freely available. So that's the easy part. The hard part is tailoring chemical models and regional scale climate models to treat the specifics of the Chicago area. And so the money tends to go into model development and into making measurements work. When I use the word model, I mean something that looks at the physical processes at work. For example, a model of the urban heat island would have to treat in a quantitative way all of the processes that heat the urban surface. You'd have to treat absorption of sunlight. You'd have to treat absorption of downwelling long-wave infrared radiation. You need to handle cooling processes like conduction of heat from the ground into the atmosphere. If the wind is blowing from the west horizontally, it tends to whip the heat away and dissipates it out over Lake Michigan. So you have to have meteorology, you have to have the thermal properties of the building surfaces, and you need to know a lot about the properties of water and the radiation fields. It's essentially a climate model applied to a very small scale. The same processes that determine the Earth's climate determine the magnitude of the urban heat island. It's just these processes are taking place on a local scale, namely the scale of a city, instead of the whole globe. One of the projects under this center involves looking at connections between incidents of asthma in Chicago and the local air quality. And so we have a team composed of atmospheric scientists who know something about air pollution chemistry, people from the health studies department who are biostatisticians, and then people from the medical school who are experts in asthma. And the question we're asking is, given the current relatively good air quality that exists in Chicago, what is the relationship between ozone amounts as measured at the ground, particulate matter as measured at the ground, and the incidence of asthma in the city? And this is something that's ongoing, but even with the relatively good air quality that exists today, there are positive relationships between reported cases of asthma and the ozone amounts in Chicago. Going forward, we want to look more at particulate matter. Particulate matter is one of the things that is implicated in health effects right now.